Hello friends, in this video tutorial we are going to learn about sequence and series. This is one of my favorite chapters and it's quite easy. Just follow simple instructions and you will be able to understand the concepts and solve the questions accordingly. So let's first of all look into what are sequences. Sequences are basically ordered collection of objects, or more mathematically, they are the functions which are mapped from natural numbers to real numbers. That is, they are basically of this form. For example, let's take Tn is equal to 2n plus 1. That is, the nth term is given by 2n plus 1. To find the sequence of this series, what we do is that we put the values of n from 1, 2, 3 and so on. So to find the first term, that is t1, what we do is that we put the value of n equals to 1 in this particular equation to obtain 2 into 1 plus 1, that's equal to 3. So the first term is equal to 3. Similarly, you can calculate more terms, which is easy to calculate. Just put 2 in the particular expression to obtain the second term as 5. So the sequence will come out to be 3, 5, 7, 9 and so on. So as you can see, it's a relation, it's a function which takes the natural number as input, that is 1, 2, 3 and so on, to give some real numbers which are ordered. That is, we know that the first term is 3, the second term is 5 and so on. So basically it's an ordered collection of objects, and objects mean here are numbers. Okay, so now if after grasping what are sequences, let's see what is the concept of series. So simply, series is the representation of the sequence, I'm mistaken here, of the sequence as the sum. It's not the actual sum, but it is just an expression of the sum, that's called the series. For example, if we consider the sequence of the natural numbers, so to express it as the series, we have 1 plus 2 plus 3 plus 4 and so on. So this particular thing is a series. Okay, if we have 1 comma 2 comma 3 comma 4, so this same thing is called a sequence then. Okay, so after this we move on to study what are progressions. There are certain sequences which follow some pattern. So the pattern following sequences are called basically progressions, and there are three most important progressions. We will discuss only two of them in this particular video, that's arithmetic progression and the geometric progression. So let's see what are arithmetic progressions. The these progressions follow a particular property, a single relation or single property which is satisfied by all the terms of that particular of that particular sequence. So to look into what is the special property of the arithmetic progressions, we have that the difference between the consecutive terms remain constant. That is to say, for example, if we consider this particular sequence, then the difference between the first two terms is equal to 2, that is 5 minus 3 is 2. The difference between the next two terms, that is 7 and 5, is also 2, and so on. If we move on to calculate the further differences between the consecutive terms, we note that the difference comes out to be constant, which is equal to 2. So we note here that it's a it's an AP. Okay. So after we've characterized a sequence as an arithmetic progression, there are two important things to note. That term the first term is represented by A, and the common difference is represented by D. As you have simply noted that this is a sequence. You might have guessed how to generate this particular sequence. So in an AP, you need only two characteristics. The that is you need the first term, that is A, and D, to uniquely determine a particular arithmetic progressions. To say this in other as you can see, the second term is given by adding the constant difference to the first term. So the second term is given by A plus D. The third term is similarly given by adding the common difference to the second term, which gives us A plus D plus D. Therefore, as you might be noting, there is a general trend which is followed. So the general term, that is the nth term, is given by A plus D into n minus 1. Similarly, if you might have noticed that to calculate the sum of the sequence up to nth term, the formula is given by n by 2 into 2a plus n minus 1 into d. To show this particular formula, there is a proof, but the proof is not required here. You simply can follow this, or you can verify this through taking the sum of say two terms and three terms and calculating it manually. Okay. So after we have studied the arithmetic progressions, there's an important term called arithmetic mean. So if we insert a number a between two numbers a and b such that a, capital A, and b are in AP, then a is called the arithmetic mean of AB. We'll talk about the importance of this particular term in later part of this video. So first of all, let's try to calculate. Let's move on. Let's try to calculate the arithmetic mean. Now we know that a, capital A, and B are in AP. Therefore, the difference between the consecutive terms, by using the general property of arithmetic progression, the difference between consecutive terms will be equal. That is to say that B minus A will be equal to capital A minus small a, which gives us that capital A is equal to A plus B divided by 2. Just remember this particular formula. It will be helpful. Okay. After we have looked into calculating a single arithmetic mean between two numbers, we can generalize this concept to finding n different arithmetic means between two numbers. That is to say that if we have we try to find out n arithmetic means, that is a1 a2 to till an, then a1 a2 an b will be in AP. Okay. So to calculate the different arithmetic means, also you have to work out a simple formula. To find out the formula, just write this particular equation. To understand this equation, this is just simply writing the general term. Okay, and the term which is written here is that of n plus 2. That is, we have written tn plus 2. So as you can see there, that for when we inserted a single number, then the small b was the third term. So as you work out that if we insert n arithmetic means between two numbers, then b will be n plus 2th term of the sequence a1 a2 an dash 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 a and b. So we have to calculate the difference, and to work out the arithmetic means, we write this equation and calculate d from this equation, which will come out to be b minus a upon n plus 1. After we've calculated d, we can simply work out different arithmetic means by just writing the general terms formula. Okay. So now we move on to next important progression, or a sequence following a certain pattern. That is geometric progression. So the important property of geometric progression is, or GP is, that the ratio of the consecutive terms remain constant. That is, let's understand this through an example. Let's take a sequence whose first term is A, second term is 25, third term is 125, and so on. So the first term is A, and let's try to calculate the common ratio between the consecutive terms. So the common ratio is represented by R, and is given by dividing the second term by the first term, which is equal to 5, the third term by the second term, that is also equal to 5. Therefore the common ratio is equal to 5. So here the general term is given by Tn equals to A into R to the power n minus 1, which you can simply see that by since this particular sequence satisfies the property of GP. Let's try to work out the second term. So second term here is given by just multiplying the first term with the common ratio, that is to say 5 into 5 raised to the power 1. The third term is equal to the second term into the common ratio, that is to say 5 into 5 raised to the power 2. Therefore the general term, as you can see, is coming out to be A into R raised to the power n minus 1. Now there's another formula of the sum of the particular geometric progressions. So it forms two cases. So the first case involves that if the ratio is 1, that is all the terms are equal, then what happens is that the sum of the sequence is basically simply the number of terms into the first term. So it's this one is pretty clear, I suppose. To work out the second formula, let's take an example. Let's take a sequence till nth term. So the sequence or the series is given by a a a to the a in ar plus a r square dash 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 the nth term, that is a raised a into r raised to the power n minus 1. So to calculate it, let's multiply this whole sequence by r. So we obtain here ar plus ar cube dash 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 ar to the power n. Okay, so if we subtract these two equations, we obtain, by taking s common here, into 1 minus r is equal to a. As you will see, these terms will cancel out, and here we have a raised to the power n minus 1 plus. So these terms cancel out, and we are left with only these particular terms, and so the sum comes out to be a into 1 minus r raised to the power n upon 1 minus r. I would request you to please memorize this formula, as it would be pretty straightforward. Just you will be given the first term and the common ratio, and you would have to calculate the sum till rth term, or say 12th term, 13th term, so on. So just remember these formulas.